Our lecture for today is Measurement of AC and DC Voltage with the Cathode Ray Oscilloscope CRO. Introduction. An oscilloscope, sometimes abbreviated CRO, for cathode ray oscilloscope, or commonly just scope or oscope, is a piece of electronic test equipment that allows signal voltages to be viewed, usually as a two-dimensional graph of one or more electrical potential differences, vertical axis plotted as a function of time or of some other voltage horizontal axis, so it is used in many fields of basic and applied research to measure time-dependent voltage signals. The CRO is used as a voltmeter with any voltage change shown on screen by an up positive or down negative movement of a bright dot. This dot is produced by a beam of electrons hitting the phosphor layer on the inside of the screen. Over time, the dot traces a graph across the screen showing voltage change against time. If voltage remains constant, the graph consists of a horizontal line. The oscilloscope is an electronic display device containing a cathode ray tube CRT, used to produce visible patterns that are the graphical representations of electrical signals. A typical oscilloscope is usually box-shaped with a display screen, numerous input connectors, control knobs, and buttons on the front panel. To aid measurement, a grid called the graticule is drawn on the face of the screen. Each square in the graticule is known as a division. As we see in this photo, an oscilloscope looks a lot like a small television set, except that it has a grid drawn on its screen and more controls than a television. The front panel of an oscilloscope normally has control sections divided into vertical, horizontal, and trigger sections. There are also display controls and input connectors. The oscilloscope is basically a graph displaying device. It draws a graph of an electrical signal. In most applications, the graph shows how signals change over time. The vertical y-axis represents voltage and the horizontal x-axis represents time. The intensity or brightness of the display is sometimes called the z-axis. How does an oscilloscope work? An outline explanation of how an oscilloscope works can be given using the block diagram. As we see here, cathode rays exist in the form of streams of high-speed electrons emitted from the heating of a cathode inside a vacuum tube, at its rear end. The electron beam emitted by the heated cathode at the rear end of the tube is accelerated and focused by one or more anode, and strikes the front of the tube, producing a bright spot on the phosphorescent screen. The emitted electrons are due to the voltage difference applied across the two electrodes. The CRT screen typically forms the anode. The electron beam is then perturbed, deflected or bent, either by a magnetic or an electric field, to scan the inside surface of the screen anode. The screen is covered with a phosphorescent coating, often transition metals or rare earth elements, which emits visible light when excited by the electrons. CRT and television. The first cathode ray tube scanning device was invented by the German scientist Carl Ferdinand Braun in 1897. Braun introduced a CRT with a fluorescent screen, known as the cathode ray oscilloscope. The screen would emit a visible light when struck by a beam of electrons. In 1907, the Russian scientist Boris Rosing used a CRT in the receiver of a television system that, at the camera end, made use of mirror drum scanning. Rosing transmitted crude geometrical patterns onto the television screen and was the first inventor to do so using a CRT. The first practical signal-generating tubes were invented by Vladimir K. Zworykin and Philo T. Farnsworth. Zworykin invented the iconoscope, which became the imaging iconoscope. Farnsworth invented the image dissector. Electronic television is based on the development of the cathode ray tube CRT, which is the picture tube found in modern television sets. A cathode ray tube or CRT is a specialized vacuum tube in which images are produced when an electron beam strikes a phosphorescent surface. Television sets, computers, automated teller machines, video game machines, video cameras, monitors, oscilloscopes and radar displays all contain cathode ray tubes. Phosphor screens using multiple beams of electrons have allowed CRTs to display millions of colors. What can you do with oscilloscope? Oscilloscopes are used by everyone from television repair technicians to physicists. They are indispensable for anyone designing or repairing electronic equipment. The usefulness of an oscilloscope is not limited to the world of electronics. With the proper transducer, an oscilloscope can measure all kinds of phenomena. A transducer is a device that creates an electrical signal in response to physical stimuli, such as sound, mechanical stress, pressure, light, or heat. For example, a microphone is a transducer. An automotive engineer uses an oscilloscope to measure engine vibrations. The medical applications of cathode ray oscilloscope CRO. 1. To study the electrical signals from the muscle through electromyogram EMG. 2. To study the electrical signals from the heart through electrocardiogram ECG. 3. To study the electrical signals from the brain through electroencephalogram EEG. 4. To study the electrical signals from the eye through electroretinogram ERG and electroculogram EOG.